we get to start off chapter 10 here in Algebra 1 with one more function. It actually is the only lesson in chapter 10 where we will be graphing. And if you can remember the tail end of chapter 9 and all of the things that happened to the quadratic functions, and then we actually graphed step functions and absolute value, and what was the last one? There was another one in there. Oh shoot. Anyway, if you can remember those and apply that knowledge to this, it should be a fairly quick lesson. But the reason we're doing square root functions here is because this entire chapter is dealing with radicals, which is another name for square roots. And we're going to, remember how I talked about, we're going to see stuff with the square root bar and leaving it alone, and how I stress not worrying so much about punching into your calculator and estimating that, because that will be exactly how you leave it. So before I get to this, I just want to show you the square root is the inverse to a square. So when I square something, if I wanted to undo it, I take the root of something. So I wanted to show you, if we look back and we do x squared, that was our parabola. It gave us a function. It was a function because, you know, vertical line test, there's only one x for every y, and so on and so forth. But the inverse of that would be the square root. So if I look at that, if I do the square root of x, because that would be the opposite, it looks kind of interesting because if you guys see that, it only gives you one. But realistically, when I take the square root of something, it should give me a positive answer and a negative answer. The thing is that this only graphs the positive answers. So if I do this, if I go negative square root of x, if we look at that, I'm going to move it this way. You guys, there we go, can see, now I'm also going to put in the straight line, y equals x, excuse me. And remember how we talked about that a few chapters ago. If it's an inverse function, it is reflected over that line. So right here, it's reflected over that line. So that is what it looks like. However, if I'm just looking at if I'm just looking at these two right here, so let me take this one off and this one off. Maybe. There we go. If I'm just looking at this, these two together would not be a function because, you know, if I'm drawing a vertical line in there, it has two spots. So every x actually has two y's other than the vertex right here. So because of that, we will only be paying attention to the positive answers. So our square root functions will simply look like this. So it's like the top half or bottom half of the parabola turned to the side. Everything is going to remain the same in terms of how we change the way it looks. All right, so let's go like this and let's just play with this a little bit. And I'm just going to get rid of all these right here so we can just look at this. All right, so let's say I have the square root of x, and then outside of that I say, ooh, I don't know, plus 3. Check out what happens. My vertex moves up 3. Just like the parabola, if we're outside of the parentheses and we add or subtract a number, it moves it up or down. Okay, so how about inside of the parentheses? Now we don't have parentheses, but I do have a square root. So if I do x minus 2 in there, see how it moves it over to the right 2? And remember, that's our h. So it's the opposite. It's x minus h. So if it's minus 2, h is positive 2. If it would have been plus 2, that would move it to the left. Okay, then we also were going to add the vertical stretch, which looks a little bit different here. Okay, so here's our first one, just like that. So what a vertical stretch, remember, is an A out in front of the parentheses. So let's just go to square root of x. Take a look at what it does. It actually, it's not quite as flat to the right. It stretches it vertically. Or if I were to put, you know, just 1/2, because that's the most basic one, x, square root of x. it flattens it out even more. So we still have A affecting it. We still have H and K affecting it. And then what do you think happens? And we kind of already know this because I showed you this, but if it's a negative A out front, so say a negative 2 square root of x, that will reflect it over the x-axis. So all those rules from our parabolas are still going to apply. Now, graphing them is a little more difficult. I'm going to need a calculator here. You're going to need a calculator because we are going to have to approximate square roots, or for when I put in the square root. So except for this one, this is going to be the square root of 0, which is 0 minus 5. We get negative 5, right? If I do the square root of 1/2, square root of 0.5 is 0.7. 0.7 minus 5 is going to be negative 4.3. I'm just going to go to the nearest tenth here. Square root of 1 is 1. 1 minus 5 is negative 4. Square root of 4 is 2. 2 minus 5 is negative 3. Square root of 9 is 3. 3 minus 5 is negative 2. So it is going to put us out there. So let's see, 0, negative 5. So down here, 0, negative 5. Then we have 1/2 and negative 4.3. So 1/2, negative 4.3. Then 1 is negative 4. 4 is negative 3. And 9, all the way out here, is negative 2. So there you have it. It should look exactly the same as that first arc, just down 5, which it does. Now, interesting here, domain, remember last chapter, all domain was all real numbers. In this domain, it cannot be a negative because we can't do the square root of a negative. So our x values, if you notice, will always start either wherever your vertex is. In this case, our vertex is on the x-axis, the y-axis, so domain is x has to be greater than or equal to 0. Now that's new, and that changes depending on where your starting point is. So it will depend on your h if you have a square root, and we'll talk about that in the next example. Range then is y values. So the y values in this case is y is greater than or equal to 5. And that is right, negative 5, excuse me. And that is right there coming from our k value. Okay, because this is plus k. So k in this case is negative 5, which is why we moved down 5. Okay, take a look at B. Now I can guess what this one's probably going to do. My h minus negative 6. So h is negative 6. So we are going to move left 6. But let's just plug those in. All right, let's plug in negative 6. So negative 6 plus 6 is 0. So the square root of 0 is 0. So negative 6, 0. Now put in negative 2. Negative 2 plus 6 is the square root of 4, which is 2. 0 plus 6 is the square root of 6, and I'm not super perfect on that, but it's going to be 2.4. And then square root of 9, which is 3. So here's my 0. Negative 2, 2. 0 is 2.4, and 3 is 3. And there you have your arc. Should be about the same as that one. Not very great. Just moving it to the left 6. So our domain, our x values, notice our x values start at negative 6. So greater than or equal to negative 6. Our range values is y is greater than or equal to 0. Because that's where y starts. Okay, example 4 takes a word problem. And I don't even know how well you can see it, is s equals the square root of capital S over 6, because we're talking about surface area of a cube. Okay, so we take the total surface area, we divide it by 6 because there are 6 squares when we put a cube together, and then we take the square root of it, which would give us one side length. Now, this is goofy because this should be a capital S and this should be S right here. Okay, like a lowercase s. It's kind of backwards. Okay, so if I put 0 in there, 0 divided by 6 is the square root of 0, which is 0. If I put 6 in there, that would be 6 over 6, or the square root of 1, which is 1. If I put 24, 24 divided by the square root of 6, or by 6 is going to be 4, and the square root of 4 is 2. So notice this little hint here. When you get to plugging numbers, especially in a word problem like this, use numbers that are going to give you perfect squares. So the next number I'm going to put in here, if I divide by 6, I want a perfect square, which is 9. So what divided by 6 would give me 9? It's going to be, what is it, 54? 9 times 6, yep, 54. Divided by 6 is the square root of 9, and that's 3. So 0, 0 right here, and then 1 is actually 6, so 1 is 6 right here. Sorry, 6 is 1, my bad, folks. 6 is 1, 24 is 2. Oops, 24. Goodness, I'm struggling here. And then 54 is way out there. I'm not even going to worry about it. So there is our parabola. Looks something like that. Now it just says, determine the side length of a cube that has a surface area of 112. So if I put 112 in there, 112 divided by 6 gives me 18. The square root of 18.6 repeating, and then when I take the square root of that, I will get 4.3. So approximately, the side length is approximately 4.3 inches. All right, moving on, take a look at what this one does. Oh, do we have to give the domain and range? We don't. Okay, this one we do. So it, and you can use this right here, but honestly, it's going to go to the left too, and it's going to stretch vertically because of our A and our K. But just to give us a couple ordered pairs, if I put 0 in there, that's 3 times the square root of 0 minus 2, we get negative 2. So 0 is negative 2. If I put 1 in there, 3 times the square root of 1, which is 1 minus 2, is 1. So 1 is 1. Whoa. 1 is 1. It's actually up there. Put 4 in there. 3 times the square root of 4, which is 3 times 2, which is 6 minus 2, we get 4. So 4 is 4. And then put 9 in there. Why did they pick perfect squares? Because we have to take the square root of that number. 3 times the square root of 9, which is 3. 3 times 3 is 9, minus 2 is 7. So 9 gives us 7. And so here is our arc, our graph, which is vertically stretched. Not only did it shift down 2 because of the minus 2, but it also vertically stretched it. Okay, so our domain, our x values, are all greater than or equal to 0, and our range, y, has to be greater than or equal to negative 2. All right, so now that we've talked about that, think about this right here. What's this going to do? It's going to reflect it. It's going to move it up 4, and then it's going to move it over 3 over here. So here is, and it's going to make it really flat. So it's going to look something like that. All right. It is an interesting addition to what we learned last chapter. All right, let's flip this baby over. Let's do some more. Dilations of radicals. So what are we doing here? We are dilating it, so that's what they called it. That's when we have something other than an A is greater than 1. So in this case, it's an 8. So this 8 times the square root of 0 is simply 0. 8 times the square root of 1/2. Well, the square root of 1/2 is 0.7 times 8 gives me 5.7. 8 times the square root of 1, which is 1, so that we get 8. 8 times the square root of 2 gives me 11.3. The square root of 3 times 8 gives me 13.9 if I'm rounding to the nearest tenth, and then 8 times the square root of 4 is just simply 16 because it's 8 times 2. All right, so here it is, 0, 0. And then 1 half gives me 5.7. 1 gives me 8. 2 gives me 11.3. 3 gives me 13.9. And 4 gives me 16. So there you have it. It's going to continue going like so. Our domain, x has to be greater than or equal to 0, and so does y, because that's where this starts. And x is going to the right, so it has to be greater than or equal to 0, and y is going up, greater than or equal to 0. Okay, translations or a reflection, look, they make a negative a here, so you can probably bet it's going to flip it, but 0 is still going to be 0, because it's negative 6 times the square root of 0, which is 0. Negative 6 times the square root of 0.5 is going to give me negative 4.2. Negative 6 times the square root of 1 is simply negative 6. Negative 6 times the square root of 4 is negative 12. And negative 6 times the square root of 9 is negative 18. Okay, so we got 0, 0. So that one doesn't change. But now 0.5 is negative 4.2. And then, let's see, 1 is 6. 4 is 12. Ooh, we're off the chart already. Down here, and 9 would be way up here. So not only did we reflect over the x-axis, but we also vertically stretched it. That's what the 6 did. The negative made it go down, the 6 made it stretch. So our domain, though, is still x is greater than or equal to 0 because it's still going to the right. However, the range, y, now that we go down, is less than or equal to 0 because that's where our vertex is. All right, you are going to continue to do that. So hopefully you're a little bit familiar with this because some of you probably already did it in Alex. That's really all I got for you. Your assignment should be on the pink sheet. You will need some graph paper, I believe. And that's all I got. Don't forget to give the domain and range. All right, good luck.